Cool. So everyone, thank you very much for joining. We're joined here by John, who's mountaineer, conquered Everest and lots of other climbings, and works to track climate change in some of the hardest to get to areas. So John will be telling us everything from stories of climbing Everest and falling down a crevasse to what it's actually like tracking climate change in mountains, what you can see where technology comes into this, and the changes they're seeing, and obviously even how the pandemic has affected this. So thank you very much to John for joining. Thanks first of all to Tracer for supporting this Tech for Sustainability series. So they're a connected value chain platform for the diamond industry, working to ensure a consumable business practice and trust in the diamond industry, demonstrating provenance, traceability, and authenticity of natural diamonds, and helping the local economies where they're mined. So anyone can find out more at community.tracer.com. That's TRACR. So big thanks to them. Big thank you to John. To everyone who's joined.
I want to show you guys a bunch of different things, and hopefully you guys will find it interesting. First thing is, why am I, on this? How does everybody know me? And let me show you my crevasse video that is kind of where things all started for me when I was working in Nepal.
Well, I'm pretty well. Keep falling that way. I got trapped here instead. For this ledge, my arm I can't use. Oh, I fell through that hole. That way, I didn't fall down, thankfully. My right arm is seizing up. I can't use it anymore. I'm gonna try and stem above that, get through that, try and hit that way. Look easy, that's my hole I fell through. That's my path, I'm gonna try. That's all I can do, I don't have a right arm. So I can't get out this way. It's too soft. I can't talk because I have a broken rib, I think. Or my chest is filling with blood or something. So I fell all the way down there. Left crawled out. So I'm gonna have to crawl through there. Try and climb up, out through this thing. Hopefully I can get out. I'm so close now. Can't use my right arm. I'm so close.
And so everyone always asks me, where's the video of you climbing out? And unfortunately, I didn't take one. I was too busy trying to get out and survive it. Even after I got out, it took me 19 hours to get a helicopter. I had 15 broken bones. I was bleeding internally, including 6 of my backbones had been broken. And yeah, it was a pretty traumatic experience. And it's just kind of the nature of doing research in the far reaches of the world. So this picture's me in Everest Base Camp collecting data. And that's basically what I was going to talk to you about today, is just sort of show you some of the work I've done in mountains around the world, and talk about how it relates to sustainability and how we've hopefully tried to help people around the world through our work. So basically, I'm an environmental scientist. I work with studying climate change and how it affects things like water and more specifically ice. And so in the case of somewhere like Mount Everest, hopefully you can see my little arrow, as I'll use that as my way to, can you see the arrow?
Yeah.
Okay. So what we do is we just sample ice and try and use that as a way to understand several different things. Because mountains jut up into the atmosphere, they collect dust and they collect pollution. And so when we study what's on a glacier, what we can find out is, first of all, is the glacier going to get darker and melt faster? And second of all, what is the pollution on it and where is it coming from? And so in the case of somewhere like Mount Everest is stuck halfway between China and India. And so by looking at one side of it, you can learn about China. Looking at the other side of it, you can learn about India, and in terms of what they're releasing kind of around the world. So I've been doing this for, God, I don't know, 15 years. I've also worked in a lot of other places studying environmental change and how climate change is affecting the planet, Africa, Central America. And I mean, it's amazing. It's one of those things where the world is transforming under our feet so fast. And it is kind of mind-boggling to think about what the future is going to look like. There's places I've gone to and 10 years later come back and, I mean, glaciers are gone. Jungles have burned away. Things have totally disappeared, and just in a rate that just, it blows your mind. So yeah, I wanted to show you some of the different, how our sampling actually works. So let me take a step back here. So this is a picture to kind of give you a sense of what we do. So Everest Base Camp that I just showed you is right here where this little central area is. This is Pumori in the background. That's Choyoyo, which is like the 6th highest mountain in the world. This is the Khumbu Icefall is at the end here, and then this is the route up Mount Everest. I took this picture from about 8,000 meters, and so this is Nuptse, for anybody who knows a little more of the detail of the Nuptse Ridge. So again, this is Camp 3 on Mount Everest. And so the idea is, what we do is we come into these environments and collect snow samples. And so here's my partner. So that last picture I just showed you is from right about here. So hopefully you see the little arrow there. And so now we're back down right here. And so what we'll do is we stop as we move up that glacier and we take snow samples. And so you can see it's actually kind of deceptively simple. You just stop with a plastic bag, and then using various parameters, you collect snow samples and carry them as you go. And the idea is that we sample on this nice flat glacier. And then this is the Lhotse face. And so I don't know if you can see. Oh, wait, no, come back. So right here is a camp, and then you have to climb through. This is the yellow band. So what you do is you climb up along through here as you're climbing Mount Everest. That's the summit of Lhotse above. So you climb up to here. There's a camp right here. You climb up through to about here to avoid all the avalanches. Then you cut across, cut through this yellow band, and head towards the summit. And so what we do is I collected a sample here on top of the yellow band, one below the yellow band, one over here in the ice on the Lhotse face, one down here on the Lhotse face, one down here on the Lhotse face. So the idea is collecting all these samples as we go. And we collect them all the way up to the summit. So this is on the summit of Lhotse. You can kind of see in the background, there's a huge blizzard that hit. That's why I got the ice forming on my face. Basically, it was one of those deals where it was a bright, beautiful, sunny day. We're collecting samples, everything's happy. And then a blizzard blew in, like essentially as we summited, because it came from the backside and we didn't know that it was coming. And unfortunately, my partner, one of the guys I was climbing with, ended up dying in the blizzard. And so again, if you saw the crevasse, he passed away. Had a lot of friends who passed away doing this type of climbing and high elevation stuff. But this is the hope, is that we have nice days we can stop and we can collect these samples. And showed you that one. Kind of going through some of the other places. This is Camp 3 on Mount Everest. So kind of at the base of this ice wall that I just showed you. Again, that's the yellow band. So now I'm just kind of going through, showing you some pictures of climbing. This is lower down in the Icefall, the Khumbu Icefall. And so you spend a lot of time climbing up ladders, crossing crevasses. And this is a moving conveyor belt of ice, and it's continually cracking and reforming. And all of these pieces, so like this giant thing that's over my friend's head, when we came back 2 days later, it had collapsed and it had totally covered this ladder in an ice fall. And so this is the Khumbu ice fall. Part of it is extremely dangerous. This is further up in the mountain. You can see as you start getting up, this is probably at about 8,100 meters. A lot of fixed ropes. You're climbing nearly vertically through this chimney as you're heading towards the summit. Let's see if I have any more pictures from there. Oh, yeah. This is leaving Camp 3 so basically when you leave at night with the idea being that the ice will stay frozen. And Erica, you'd hate it because it means you have to climb at the coldest part of the night. But it's great, but I mean, because it is the coldest part, so the ice isn't melting and it's not collapsing and it's not cracking underneath you. So yeah, and it's funny, it's kind of hard to tell, but you're actually climbing up this rope, so it's almost vertical, but it looks like they're just kind of walking on a flat land. And then this is looking up towards the summit, and you can see how steep it is and how everything's overhung. Again, you can see a climber's right there, and there's a couple more climbers over here moving up through into the chimney as you start heading up. All right, so that's basically some slides from climbing Mount Everest and Mount Lhotse, to give you guys just a little feel of what 8,000 meter climbing looks like. But the thing is if you just sample the snow, you're wasting a lot of time. And so the program I lead, the American Climber Science Program, we spend a lot of time collecting data while we're approaching the mountains and while we're in base camp waiting as we're acclimatizing. And so I work with a team of scientists, hydrologists, toxicologists, physicists, and we collect a lot of data as a group, and that way you have synergy between what you find. And it allows us to answer a lot of societal questions. So we can talk about things like, what is the best water supply for a village? Or what are some of the alternative economic avenues that villagers could approach with climate changing the landscape around them? And so the key way that I work, and a lot of scientists work, is that we just take a GPS like this one, and you go and you collect data for that point. And so it's like a snapshot in time. And now I can go back every 5 years, every 10 years, and revisit this same point and look and see how the environment's changed. And it's one of those best of all possible worlds, because it forces you to get out into the world and see what's out there. And so it's kind of, I do lab work and take the samples back, and I do computer work. We use NASA satellite imagery and compare the satellite imagery to what we find on the ground. But at the end of the day, you have to go onto the ground. And so that's what's led me to be part of the Explorers Club, led me to found this climber science program that I'm part of. And that's basically what we're doing, is we're collecting data on vegetation and water quality and what the local people are doing down low. And then as we move higher, we collect those snow samples I showed you. So let me go down. And a lot of people don't realize, in somewhere like Mount Everest, there's a lot of people that live in the national park. And I think in Britain, it's probably the same as it is in the United States. Our national parks are protected. Nobody really lives there. You just kind of come to visit and you leave. But the national parks in most of the rest of the world were created where people are already living. And so your management of the park and how climate change and how tourism affects the park is going to be intertwined with how the local people live. And so in the case of Mount Everest, for example, down low so these are rice paddies and irrigated agriculture. And then as you move up, you have less of the irrigated agriculture, more grazing, and then it becomes just kind of pure tourism and the various highest levels. So that's the other thing we're looking at is down lower is some of these things. And so we work like this. Is my friend Eric. He's a biologist, the director of the herbarium for the Pacific Northwest. And so here we are trekking there in the Mount Everest region, collecting plant samples and looking for unique plants, as well as trying to collect samples that allow us to connect to the plants that are in Mount Everest with the plants that are in Europe, that are in North America, that are in Peru. And so we can see the kind of genetic structure of alpine plants around the world. So again, by doing these integrated expeditions, it allows us to not just learn about water, not just learn about ice, but also learn about other things as well. So again, just another picture of collecting data. More data pictures. And I threw a bunch of different ones in because I mean, that's what you spend your time doing, is you're trekking, and you stop every 250, 350 meters, depending on the terrain, sometimes 500 meters. In Africa, we did a lot of 500 meters, and collect data samples. Showed you this one. One of the things is, a big part of what we've always done is work with local students and professors. And so this is a graduate student, a Nepali graduate student. He actually, after this, had planned on coming to the United States to work on a PhD. COVID shut all that down. But that's a big part of learning and working in these societies, is not just coming and visiting and collecting data, but also working with the local people and training the next generation of Nepali scientists, because they live there and they can go out every year and collect data on what's going on. In this case, this was another botanist. And so we're collecting data on simple things like this rhododendron behind him. Nepal has something like 50 species of endemic rhododendron, and identifying those and learning about their genetics is a kind of an open research question. And so that's another thing that we were doing there. One thing is because we are in the field, we are working for, weeks on end. We have to, everything's done with solar power. So we're collecting, we're carrying GPSs, we're collecting, carrying radiometers and all sorts of different tools. And so we end up carrying a lot of solar panels and trying to keep everything well hydrated. Actually, this picture is kind of funny because this guy was British and came on our expedition, and he brought his dad's ice axe, or it was his grandpa's ice axe, so that he had used on an expedition back in the 60s or something on Everest. And so it's wood and it weighed like 30 pounds. But that's a big part of what we're trying to do is, again, experience everything there is when we're out doing these things. And Nepal, of course, is a very poor country. We work in Peru, which is, a lot of people tend to equate Peru and Nepal, say, oh, they're both very poor, but Peru is substantially more wealthy. Nepal, a lot of people don't realize that is one of the poorest countries on earth, like the bottom 10. It has the same gross domestic product as Haiti. And it's less than $1,000 a year that most people are making on average. And so you see people carrying, these are all soda bottles. So this load that this guy, and again, the guy's probably 5'1", and he's carrying over 100 pounds of Coke and everything else up the trail. Another data collection image. More data collection images. Again, this is another Nepali student, botanical student. More data collection images. You start to see the trend here. That's what we spend a lot of time doing. And one thing that's really great is we also, in addition to working with the students, so on the left is a student, and then on the right is a local Sherpa. And one of the things is, if you want to really know the landscape, students can identify species and kind of pull everything into a scientific framework, but it's the local people who really know what's going on. So when I've worked in Africa, and then I've worked with the local people. When I've worked in Peru, I've worked with the Quechua. When I've worked in Nepal, we work with the Sherpa. And we ask them, all right, well, what do you call this plant? What is it used for? Is it, if someone gets pneumonia, do you give them this, or is it a tea, or does it have no uses? Do the cattle eat it, and so forth? And so that ethnography, by pulling in how local people work and how they use the things, allows us to understand, all right, traditionally, how's the landscape been used? And then the most important question we always ask is, well, all right, climate's changing, there's more people in here, so human use is changing. How has that affected use of your resources and so forth? So again, kind of combining the two. And the thing that I found most stunning that I never would have expected in the kind of Everest area is the disappearance of the yak. When I first went there, probably 15 years ago, yak were everywhere. The local people grazed them. They used them for transport and meat and milk and hide. And it was the substance, it was the foundation of the Sherpa economy. And then when I went back, I just went back 2019 at this point, and that's when we climbed Everest and Lhotse again. And there were no yak, or almost no yak. And the reason is most of the Sherpa have started moving out of the highland areas. Tourism has been so lucrative for Sherpa compared to the rest of the country that they essentially just kind of make their fortune, and then they want to leave that area because there's no schools, no hospitals, and they want to take their children to Kathmandu so that their children can get an education, so their children can gain the skills that they need to really advance in the world. And so they basically send their kids and take their kids with them to Kathmandu. And so as the Sherpa have disappeared, the yaks have disappeared because the people who have moved in to replace them from the lower elevations don't have a tradition of grazing yaks. And so it used to be that a lot of gear was transported via yak, and yaks are terrible. We were trying to move yaks up a mountain to climb, and a storm blows in, and I swear they just wanted to walk off the cliff. And so we're pushing them, the Sherpa are pushing them. We're trying to say, no, that's the way, stay off the edge of the cliff. And they're obstinate vehicles, they're animals. Thankfully, we didn't lose any, but it's kind of mind-boggling to deal with them. But now they pretty much have all been replaced with donkeys. And so it's changed the just nature of the Khumbu Valley. And there still are some yaks, don't get me wrong, but that's just one of those changes that's going on. We talk about climate change, but it's really those human changes that have as big or bigger impact right now. So let me see if there's anything else I want to show you from Nepal. So I don't see the chat, and I haven't gotten any questions. Does anybody, let me stop because I've showed you a bunch of stuff from Nepal. Does anybody have any questions?
I mean, I've got a first question. Why were the yaks replaced by donkeys?
Because, well, donkeys is so in Nepal, everybody sort of lives based on their elevation, and the Sherpas live at the highest elevation, and you have to have yaks because of the cold winters. But the winters have gotten warmer, and all the Sherpas have left, and the people who came in don't know how to deal with them. I told you how hard it was. I'm pushing them and doing everything else. They're just tough to deal with. But the donkeys, on the other hand, are super easy. Everybody knows them. And so when the people from the lower elevations moved up, they brought the donkeys with them, and they're like, I don't want a yak. I don't know what to do with a yak. And it's just the donkey hooves are much harder, and so they cut the path and make it more muddy. The donkeys crap a lot more, and so the trail, it's really sad to see how it's just those little subtle things have changed it. Because I think yaks are cute when they're not being obstinate. They're kind of fun. So
Well, any other questions? For anyone that missed the start, we do try and make these as interactive as possible. So if you've got any questions, there's a raise hand button that you can click on to ask John directly, or type any questions in the Q&A. So yeah, we'll get back to questions if that's okay.
All right. Well, I don't see anything, so we'll talk about Peru now. And like Nepal and Peru, basically, Peru is kind of it's like a wonderland. It's like, it's not as nice as being in Switzerland or something, but it's just so much easier to deal with. In Nepal, if you want to go climb something, it takes a month and 2 weeks to get to your peak. In Peru, it's so much simpler. It's light, it's warm. You can get to like this campsite. Well, this campsite actually takes 3 days to get to, but most the campsites you can be at within a day from a village. And it's much lower, it's far warmer. But having said that, I mean, there still are, so this is crossing a pass in a blizzard, and you can see, so that is probably a 2,000 plus meter drop that we're trying to negotiate. And so it still gives you a lot of the same mountainous goodness, but it's just the scale and the logistics are not nearly as difficult. And so this is where we normally work. We work here every year. I work in Nepal probably I try and do it once every 5 years. And in Nepal, because Everest and these high 6,000-7,000 meter peaks are so difficult, I pretty much only bring a small team of expert climbers, so 5-6 people. In Peru, on the other hand, it's much more straightforward. I bring teams, so we have rope teams of 3 or 4. And I've actually taken the park superintendent's kids up a peak, the Peruvians, and granted they live in Huaraz, so they live at 3,000 meters and they were well acclimatized, but his high school kids I took to the summit of a 5,000 meter peak. And so I've worked with people all the way up to age like 75 and gotten them to the summit of 5,000 meter peaks. Here I'm able to bring, stockbrokers from Wall Street, artists, engineers, and just a whole variety of different people. And anybody who's watching who'd be interested in joining an expedition, Peru's a great stepping stone, because a lot of people who are like gym climbers or boulderers or sport climbers who've just done some outside climbing but are interested in going to alpine stuff, that's what we really try and do. So let's take a look here. This is a peak. So this is an example of a peak that you can't really climb anymore. And this picture was taken about 10 years ago. The peak is 5,400 meters maybe tall, so it's one of the lower peaks. And it used to be a great, easy, fun peak to climb. And in the last 10 years, all of this snow that you see in the picture has disappeared. Along the skyline up here is a glacier, and it is fractured and broken and disappeared. And unfortunately, my slides are out of order. I was supposed to have a picture that showed you the kind of after. But yeah, so because Peru is at the equator, and it's much lower latitude, and so climate change is hitting it harder. And because it is lower in elevation, climate change is hitting it harder. And so everything here is accelerated compared to what we see in Nepal. And so it's a much more dynamic place to work. But again, the benefit of it being close to the equator is, lightweight tents, you're clamping on rock instead of on glacier. And it's just a much more, there's a little lake here. Yeah, you can, we were talking about bathing. You can, if you want a nice ice cold polar plunge, we have a nice coming off the glacier lake right there. But the other thing with Peru is it's stunningly beautiful, and it's more on a human scale. So you can just really appreciate the beauty, and it's not so tall that it's kind of out of your sight. This is Alpamayo, which is just a fantastic climb. We've done it quite a few times, sampling. And the route from where we're standing now, as you go down into this base, you climb up through here, cross this Bergstrom right here, climb up, straight up through here like that to the summit. And it's probably my favorite climb anywhere on earth. It's just straight, beautiful ice, straight up the channel. Probably 60-meter rope, 12 pitches. So say, well, by the time everything's said and done, maybe 1,000 meters of climbing. So it's just it's a fantastic place to work. So God, these are all out of order. So one of the things we do is work on, I'm kind of trying to follow the order that this was in. So so again, we are sampling different things. So we collect the snow samples. And so I showed you the collection in terms of, we take the snow in a plastic bag, we bring it back to camp, we boil it, we run it through filters and do various things. And so what we get left with is these little vials. And so what this is this is roughly a liter's worth of snow run through a filter. And so you can see most people tend to think, oh, snow, it's white, clean, pure. But these were white, clean, pure looking bags of snow, but when we filtered them, you can see that in fact they were very dark. And so snow really does trap moist dirt and dust very effectively. And we can take these samples and run them through and find out, just how, what's in them. And let me see if I have any more of those. So again, what we're doing is we're collecting the snow, we label the bag. So this is on the summit of a mountain. And then I think I've got one of us filtering. God, interesting. Oh, and then, all right, doesn't look like I have the filtering one. So that's one thing. And then I talked about how we also are going to collect water quality samples. And so this is a spring coming out of a mountain slope, and we called it the Dorito spring because it looked exactly the same color as nacho cheese Dorito bag, but it basically is incredibly acidic. So you're walking along the side of a mountain, and pumping out of the side of that hill is this bright red water, and it was down to the pH was 2, so it's more acidic than battery acid. And so we're collecting that kind of water. So this was up at about 4,500 meters, and so we followed this spring and collected samples all the way down. And as it met other springs, and we saw how that acidity so slowly was attenuated as it affected other things. And what we found is when you're up high where the water is super acidic, as you might imagine, there's a lot of dead cows, and there's a lot of dead vegetation, and there's a lot of dead things going on. And that sort of disappears as you go further down. But if you're a village, you can't drink this water. And so that's one of the most important things that we're trying to do is I work with geologists, and we try and create these maps of acidic versus non-acidic water. And so by tracing each of the streams and seeing which ones come from the acidic sources and which ones don't, it allows local people when they're planning, all right, what's going to be our next source of water? And, they can kind of plan. So I'll just show you guys. So I apologize you're cut out of order, but it's fine. We're relaxed. So this is just people, some of our, I take a lot of students. And so here, this is in the middle of a glacier, or what was a glacier. Now the glacier's totally melted. So all that's left is the scree in the background and the rock piles. We also, again, go to summits. And so a lot of the students are doing things like, a full handstand, doing the jumps. And here he's just reflecting and enjoying the being there. But again, so we took this picture, and then the next picture is we're collecting our samples. So, but again, it's just in Peru, it's a much more vibrant landscape and much closer in terms of the beauty. This is your cold camp shot for you, Erica. This is it.
Not my idea of fun.
What's that?
That is not my idea of fun.
Well, this is so I took that picture with the beautiful, yeah, so this picture, that camp, that's that camp. So you can see it's just, you're kind of on the edge of this thing. It's an amazingly beautiful country. And again, we're collecting snow samples there all around. This is from the summit of a peak, and looking down, you can see, so we can go on, I've climbed this peak, and this is an amazing snowboard or ski descent through here. And again, we just sample the glacier all the way up through to the summit. But this is one of my favorite places. Some more climbing pictures. This is what our base camp looks like. Typically in these Peruvian expeditions, like I said, I only take 5 or 6 people to Nepal. In Peru, we'll have groups of more like 20, sometimes maximum 25. And so this is what our base camp looks like. We typically are traveling with the yellow tent's our cook tent, and the white tent's our dining tent. So everyone brings their own tent. You kind of spread out a little bit, and then we have Quechua cooks who we eat, so we eat the local foods. And one of the reasons I wanted to show this picture was both the vegetation. So this larkspur, this lupin, which is right here, this flower is exactly the same as the lupin that we find in Nepal, for example. So, but more importantly, in the background, see the orange water? So that is coming from that spring I showed you guys. So it was bright red, and then I showed you one picture at the very bottom where it was kind of normal looking. Well, this is in the middle, so it's still bright red. And yeah, we can't drink this water. You can see it's redder if you look. I don't know if I can zoom in here very well. And then the orange, so we actually have to walk, even though the camp's here, we have to walk quite a ways to get water that's fresh enough to drink from a spring. Showed you the sampling. Oh, there's another type of sampling we've done, is try to get over time. So here I'm rappelling into a crevasse, and so I just sampled every half meter all the way down the crevasse. This is climbing up through the crevasses. One thing is, in Peru, as I said, the glaciers are melting more quickly, and so the climbing that we do ends up being a lot more difficult because it is so much more broken. In Nepal, effectively, there's just one place that has this kind of a broken glacier, and that's the Khumbu Icefall that you're typically climbing on. Whereas in Peru, you're doing quite a bit of it. So, and this is from a high camp. So I don't know if you can see, there's a trail right here. And this actually picture was this cover of a fire journal. And the reason it was is because this clear area right here, we studied the fire. That was a fire. And it was a lot of the local people use fire as a tool to enhance grazing. And in this case, it was there's a trail that runs right along here. Hopefully you can see it, and kind of goes through here, and it goes to a base camp. So there's a base camp here. And then actually, well, if you're looking, if you can see, hopefully there's a trail that keeps going here, and that's that glacier that I showed you earlier. And then you can climb these peaks. But a tourist dropped a cigarette and so burned this area. And so it was nice because we were able to compare what a tourist burn looks like with typically this area gets burned by the local people for their grazing enhancement. So again, when you're studying the science, being able to look at how local use versus tourism is affecting things. The other thing that's, I think, super cool about this picture is, so I got this wonderful guy named Joaquin. He's Quechua, and he's like 65 or something. And he's our cook, but he used to be a mountain guide. And so he actually carried a bicycle up to the summit of this mountain so that some French dude back in the 70s could mountain bike down it and do the first mountain bike descent. And, of course, I was laughing. I was like, dude, if you don't carry the mountain bike up, the descent does not count. But he told us that when he was a kid, all of this gray area here was covered by glacier. So this entire, basically everything along this line was covered by glacier 30 years ago. So really great place to see both the effect of the fire, but also how the things are retreating so quickly there. So it looks like, what do I have left here? Just kind of pretty pictures, nice summit jump. Here we were climbing and collecting samples, and we ended up running into 2 Peruvian climbers who were just climbing on their own, and they wanted to take pictures of the crazy gringos collecting snow samples. This picture I really love because this guy in the back who looks like he's kind of having trouble walking, he was a physicist, and he had bought crampons 30 years ago when he was in grad school, and his dream was to climb a mountain. And he studied the effect of radiation on snow, but he'd never climbed a mountain until he came on our expedition, and he pulled out these old antique crampons and ice axe, and he ended up writing an article for a magazine called like 30 Years Later or something, where he detailed, being able finally to climb a mountain. This is another route that has disappeared. So you can see kind of coming through here. Now this entire thing is disintegrated and broken apart. Let's see what else we have here. This is a picture. So I showed you that Dorito Spring, the bright red one. That starts right there where that wet spot is. So basically right there on the rock is where the Dorito Spring is. So the Dorito Spring flows into this lake. There's another Dorito Spring over here that flows into the lake, another one over here that flows into the lake. So this lake has a pH of just under 3. And so it's incredibly acidic. Again, all the cows that come up here and drink from the lake die. And then that flows down around this corner and starts flowing down until eventually it hits our camp. This is Chopacalqui, which is it's one of the top 10 highest peaks in South America. It's like 6,500. So we've sampled along that ridge, snow. A couple more of our volunteers jumping for joy. The thing that we've done is we've worked with local people, and I mentioned that there's grazing that goes on in these areas. And so here what we did was we put up a fence, a 10 meter by 10 meter fence. And the idea is we put the fence up and then collected all the vegetation and the soil inside the area. And the idea is you keep the cows out. And so we've kept the cows out for 10 years now. And so we've been able to track how the vegetation has changed within, how the soil has changed within, and compare it to what it looks like outside. And that's one of the terrible things about COVID is we had all these long 10-year, 15-year records of continuous data. And now we've lost, in some cases, 2 years worth of data. And so we're really hopeful to get back in July of this year to finish collecting the data. This is my favorite summit shot of all times. I mean, the back bend and the point, it was, she's like 18 or something, so she's got the flexibility. My back would snap into pieces. And this is Chopacalqui. So I just showed you a picture from the other side. I told you this is the highest point in Peru and like the 3rd in Latin America. And this is the one that the guy mountain biked down. So right down that slope right there. And we've collected samples on both that peak as well as this peak, as well as that. Another nice, pretty sampling pictures. We're descending, sampling. For now, we're climbing up and taking samples. So again, this is one of those that we can't climb anymore because it's disappeared. There's our camp, another camp. There's some refugios, and the refugios are really interesting. The refuges, you've got a lot of them in Europe. We don't tend to have them in the Americas as much. And this was a national park, and so they were like, absolutely no refuges would be built. And an Italian Catholic group that was used to having refuges in the Alps said, all right, we want to build a refuge down here in the Andes in the Cordillera Blanca. And the National Park Service was like, no, you can't. And they said, but we're Catholic. And they got all the local people to say, well, we want a Catholic building there. And so they managed to get those put in, and it's greatly increased the access to these areas. And same thing, it changed all of the dynamics of the use and everything. But again, if you look at this picture closely, you can see the red rock. And so this is another one of those acid springs coming down into the area. And so we can't use that water. Instead, we use a spring that's up here. All right, just a few more kind of pretty pictures. You've seen the Dorito Spring, out walking, collecting data. And yeah, that's a picture. This is the final thing about this area in Peru where we worked, is that there's multiple 1,000-year-old cultures that are here, and pretty much everywhere you work, you stumble on ruins that are, again, in 1,000 years old and older. I went to a boulder to I wanted to climb it, and I saw a little space underneath it, so I kind of pulled the grass back and looked inside, and there were at least 5 skulls that I could see that were, there was an archaeologist with us and kind of looked at it and marked it for excavation. But yeah, they said they were hundreds of years old. It was an old burial site, and it was just, we kind of found it out in the middle of nowhere. So these little, you can see how most of the hilltops are barren, but there are these areas where there are the terraced hills. And again, these were built by the kind of pre-Incan civilizations, so thousands of years ago, and they're still being used for agriculture. And yeah, just having that sense of history when you're in these places is, I don't know, kind of the way I figured I'd finish up with my pictures. So hopefully you all have some questions.
Amazing. Yeah, thank you so much. First question from Alyssa: how is your work funded?
So we kind of,
and how much do those expeditions cost also? I mean, it's, how long is a piece of string question, but roughly.
Well, so first of all, the cost. I'm a dirtbag. I mean, if you climb, you're poor, and so we laugh. We call ourselves dirtbags because you throw your sleeping bag in the dirt and just sleep. But these expeditions are a little nicer. Like I said, we do have dining tents, and we have donkeys carry gear in, or yaks, depending on where we go. And but they're not fancy. I mean, there's, you're still, it's a toilet tent with a hole in the ground where you're going to the bathroom and stuff, and they're washing the dishes and everything in clean water, and so it's everything's sanitary and it's really nice, but it's not fancy. And it basically, we break our expeditions in Peru into valleys, and so each valley is roughly a week. And so during that week, what I charge is about $850 for basically each volunteer has to pay his own expenses. So you got to pay for your own food, transportation, and so forth. And so it costs about $850 a week for all of that, for the cooks, for the donkeys, for everything. And then the science, in terms of the gear, the supplies and everything, we work with the National Science Foundation, and a whole bunch of different agencies like that. We also work with the Fulbright Foundation, the Peace Corps, and other groups like that for a lot of the human work we do. So we've done things like we've installed solar panels in schools. In areas like this, we work with people on agriculture in terms of diversifying their agricultural outputs and so forth. So science is founded. The science itself is funded by National Science Foundation and their science groups. The human work is funded by kind of a lot of charitable groups, and then people pay their own expenses. But basically, there's no salary. I'm a volunteer. I have a day job and as a professor, and no one makes any salary. We don't, all our money either goes towards doing the research. We do provide funding for the Peruvian and Nepali and like African and their students to join us on expeditions. But yeah, so that's how it's funded. And yeah, $850, like if you paid for a guided expedition to climb the exact same peaks that we climb, it's like $2,000. So it's one of those things where it's great because you're paying less than half and you're making the world a better place. So that's why we've had a lot of success. And we've had a bunch of British people join us. My partner on Everest, and he just done a bunch of climbing with me, was from London. So we call ourselves the American Climber Science Program. And people are like, do we have to be American? It's like, no, Australian, German, we've had everybody. So
Cool. And one question from me: how can you track sort of climate change when you've got all this extreme weather, like blizzards and everything that happens up there? Or is it a trend that you've got to be there sort of year round to track all of that, or how does that work?
well, that's the idea with snow. Is the snow is there year round, and by collecting the snow, it's creating the record for us. And it's the same with the water and the vegetation. The water, by looking at the vegetation every year and comparing what's on the ground to satellite imagery, we can look at how, because the satellites are there every year and every month, and so we can look at how the vegetation changes. And then with the water, when it rains, it takes about a season for it to kind of percolate through the system and come out. Mm-hmm. And so same thing, there's a delay built in. And so as long as we're there every year, we have these snapshots of what each year has looked like. But then we do work, that's why we work with the local people. We do have students who collect every month and even more frequently in areas and kind of supplement what we do. So that's kind of the thing. But yeah, that's why I go back to a lot of the same areas year after year.
Cool, thank you. One question for me: you said about the spring that had the pH 2 acidity, the Dorito spring, and there's a lot of dead cows.
Well, and the funny thing was, we asked a toxicologist. We had a toxicologist with us, and we were like, can we drink this water? I mean, is it going to kill us? And she started laughing, and we thought, oh yeah, don't be dumb. Of course you can't. And she's like, no, you definitely can. It's like drinking a can of Pepsi or something. It's not. But and then even more, she said, and it's way too acidic. Nothing will be alive. So there's no bacteria. There's no giardia or anything. So it actually is kind of good to drink. And some places I've had to drink it up at the high camps and stuff, and it does. It tastes like kind of like orange juice, but like a soda orange juice. It's not good. It's like the bad version of a soda orange juice. But yeah, you can drink it. So
how do the cows not know? I'd have thought they would have some natural built-in intuition.
Well, I think it's just if that's all you're drinking and you're drinking a lot of it, and it's already, because they're so high and cold, and there's a lot of insects and disease, and they don't have enough salt. There's a lot of limitations. Like I've run into, there was one expedition there was a cow charging some of my students, and I had to go and grab the cow by his horns. And, I'm trying to do like in the rodeos you see on TV and throw him to the ground, and I couldn't. It's way harder than it looks. But he was skinny enough that I was just kind of moving him all over the place. And that's why he was charging, because he was just kind of crazy, because he had, there's disease and all these other things in a lot of these cows. So.
And are they being taken there by the farmers, or are they there relatively naturally?
No, they're definitely, it's crazy, because they're like, you go into a valley and there's, I don't know, say 100 cattle across the whole valley. And like our cooks would have, they would say, yeah, I'm going to go, he would take a thing of salt to his cow, and he knew exactly where it was in the valley. They basically take them to a section of valley and they stay there. And so each of the local people know, all right, my cow's in this 100 square meter area, and they kind of just hang out there. And they use the salt to keep them in the same locations.
Right.
So they always bring the salt to them, and the cows don't want to wander too far, because the salt is the kind of limiting factor. And it's cool because they don't eat the cows themselves. They use it as like we would use a bank. Basically, whenever they make some money, they buy a cow and then grow it for a couple, 3 years, and then that's the interest they've made off of their investment is when they sell the cow for tourists. So.
Okay, cool. The final question, conscious of time. Are there any, like in the Antarctic, you've got the permanent research bases? Do they have anything like that there, or is it just too impossible to maintain other than base camp?
You mean on Everest?
Well, yeah, or sort of above, say,
So
7,000-8,000 meters.
yeah, in Peru, there definitely are permanent weather stations and so forth, and things because it's lower in elevation. In Nepal, the problem is the weather is just so extreme. Even on Denali in the U.S., which is only 6,000 meters, but it's got similar temperatures. The U.S. has put station after station up there, and the winds destroy them. And National Geographic put up a permanent weather station on Everest at 8,000 meters this past year when we were working with them, and we'll see how long it lasts. But yeah, typically that's been the issue. There is an Italian station at a little over 5,000 meters near Everest Base Camp, and that pretty much has been the highest permanent station that I know of. And that's Pyramid Station, and it's Italian, like a European conglomerate runs it, I guess. But beyond that, yeah, the storms are just so bad they rip the stations to pieces. I mean, it's hurricane force winds up there during the most of the year. So
cool. No, hey, John, that was super interesting. That was amazing. Thank you so much. Like, from me and from everyone else, really grateful. Super interesting. I'd love to keep looking at more photos if you've got any more that we can go through. But no, really interesting. Thank you so much. Thank you to everyone who joined.
Great.
And for the questions.
Great. Okay, yeah, no, I was happy to do it. It was a lot of fun.
Super grateful, and see you soon. Catch up soon.
Okay.
Look forward to it. Cheers. Thank you. Bye.
Bye.